In this video, I'm going to talk about an abbreviation that we're going to do in logic, dropping parentheses for disjunctions and conjunctions, and I'll explain to you why we're not going to do the same thing for conditionals and biconditionals. So, consider the following propositions that we find in the textbook. T, today I will give a lecture. M, today I will go to a department meeting. L, today I will return library books. Now let's say I'm going to do all three of these things today, so I actually can save some time if I put these all into one big conjunction together. But what's that conjunction going to look like? According to my rules, I'm going to have to put two of these guys into a conjunction and then throw that conjunction into another conjunction with a third one. So I could have T and M and L, or I could have T and M and L. So which one of these is right? Well, interestingly, they're both logically equivalent, meaning that they both have the same truth values no matter what combination of truth values you assign to T, M, and L. It kind of makes intuitive sense. You know, T and M and L, all three of those are going to have to be true in these conjunctions for T and M and L, or T and M and L to be true. So these are going to be true only in one case and false in the rest of the cases. So intuitively it makes sense, but we can go ahead and look at our truth tables to make sure that we know that. We assign all of our truth values to T, M, and L individually, and then when we do so, we have to build that first conjunction in proposition 1, M and L. Only true when both conjuncts are true. Looks like that happens in rows 1 and row 5. And then T and M and L, again, only true when both conjuncts are true. And looks like that only happens in row 1. So row 1 is where this conjunction comes out true, otherwise it's false. Then looking at T and M and L, T and M only comes out true when both conjuncts are true. That happens in rows 1 and 2. And then that combined with the and L, only true when both conjuncts are true. That only happens in row 1. So yep, these two are equivalent propositions. However, psychologically speaking, it sure seems like they're a little bit different. I mean, just a little bit, right? You look at the way that they're bundled together, and it looks like first we're bundling together meetings and library goings too, and we're only later on throwing in that giving lectures. And in the second proposition, it looks like, you know, giving a lecture and going to meetings is tied together, and then afterwards we think about going to the library. So psychologically speaking, it seems like we have two different propositions here, but really, like in natural language, we want those conjuncts all to be the same. We want them all to be equal, because all I'm saying is like all three of these things, right? It would be nice if we could have that. So one thing that would be kind of nice here is if we drop our parentheses here, if we would just be left with T and M and L, that would look a lot like what we mean in natural language. It would be ambiguous between T and M and L versus T and M and L. But that's okay because they're logically equivalent, and it seems to be like closer to what we mean anyway. So now notice that our rules won't allow us to do this, but this is a little shortcut we'll do. So when it comes to just a row of conjunctions, we're just going to go ahead and drop the parentheses. We're going to make it ambiguous exactly what we mean, but that's okay because any disambiguation is going to come out to mean the exact same thing, and we're going to be a lot less confused when we look at these conjunctions. Note also that we're not limited to just 3 conjuncts, right? Any row of conjunction is only going to come out true when every single conjunct is true. So you could throw out on any amount of conjuncts, and there's only going to be one line where they're all true. And we have a very similar situation with a disjunction. So consider, again, from the textbook, 3 propositions. I will have scrambled eggs for breakfast. I will have pancakes for breakfast. And I will have baked beans on toast for breakfast. Apparently that's a thing. I looked it up, man. I was like, what? Baked beans on toast? I mean, of all the things you can think of on toast, toast, jelly, yes. Butter, check. Baked beans. Somebody came up with that, and it's a horrific idea. I don't know. But in any case, that is a breakfast in some places. So now let's say I wake up for in the morning, you know, and I'm like, I'm going to have one of those 3, you know. I want to have not all 3 of them necessarily. Maybe I'll have all 3 of them, but I want to have at least one of those things. Well, I could put those all into one big disjunction here. But again, like our conjunction situation, our rules say that we have to bundle 2 disjuncts first together, and then we can bundle that with a third one finally in a second step. But again, that's not exactly what we mean natural language speaking. I mean, logically equivalent for sure, Because remember, and again, looking at this intuitively first, disjunction is true when at least one disjunct is true. So piling them together like this, they're always going to be true unless every single one of these things is false. Unless S is false and P is false and B is false. That's the only time when these disjunctions are going to be false. So these are going to be logically equivalent. Let's go ahead and look at the truth tables real quick just to make sure. Proposition 1 here, first we'll have to build that P or B. Only false when P and B are both false, and that happens in row 4 and 8. Then S or P or B, again, only false when S is false and P or B is false, and that only happens in row 8. So otherwise it's true. Then look at the second proposition here. S or P, only false when both S and P are both false. That happens in rows 7 and 8. And then looking at the bigger disjunction, S or P or B, only false when both of those disjuncts are false. That only happens in row 8, otherwise it's true. So these are logically equivalent propositions. So we could do a very similar strategy to the conjunction. We'll just drop all the parentheses within these disjunctions and just string them all together, and we'll kind of know what we mean. Again, our rules don't say that we're allowed to do this, but it's going to help us to understand things, and quick shortcut. Now, it's not the case that we're going to do this for conditionals. Actually, interestingly enough, this exact case happened in our last video. I don't remember which problem it was, but one of our other problems was just like this. So consider if P then, if Q then R, versus if P then Q then R. So we'll build these truth tables to see if these are logically equivalent. If they're not logically equivalent, then dropping parentheses is going to make it ambiguous on which one of these two propositions we mean, and we could have some serious repercussions here because the two are not exactly equal. They don't mean the same thing, so we'll want to keep our parentheses. So for the if Q then R in that proposition 1, only false when Q is true and R is false. Looks like that happens in row 2. Looks like that happens in row 2 and row 6. And then for the bigger conditional, only false when P is true and if Q then R is false. Now, the if P then Q for proposition 2, only false when P is true, Q is false, and that happens in rows 3 and 4. And then for the bigger conditional, only false when if P then Q is true and then R is false. That happens in row 2 and row 6 and row 8. So I know these two are not logically equivalent propositions. They are jointly satisfiable, but they're not equivalent. So dropping our parentheses here would just cause confusion, and we're not going to do that. The biconditional is where things get interesting because, interestingly enough, biconditionals in this form are logically equivalent. However, it is confusing to drop the parentheses, and you'll see what I mean in just a second. So let's go ahead and do the same thing. We'll look at it, P if and only if Q and if and only if R versus P if and only if Q if and only if R. So that first Q if and only if R in proposition 1, true when Q is true and R is true, and true when Q is false and R is false. In other words, the biconditional means both propositions that make it up have the same truth value, whether they're both true or they're both false. So it looks like that is true in rows 1, 4, 5, and 8. And then we compare that to the P if and only if Q if and only if R. And again, true whenever they have the same truth values. That happens in row 1, row 4, row 6, and row 7. Let's see if that's the same truth values for the second proposition here. So P if and only if Q, true when P is true, Q is true, or P is false and Q is false. That happens in rows 1, 2, 7, 8. And then again, another biconditional, true when they both have the same truth values. That happens in row 1, in row 4, and row 7 and 8. So 1, 4, 7, 8. Both of these propositions are true in those rows. So these are logically equivalent propositions. However, think about stringing them up like we did the conjunctions and the disjunctions. So P if and only if, Q if and only if, R. Now you would think that P if and only if Q if and only if R would make just as much sense as P and Q and R strung all together like that. But P and Q and R and S and T and U and V and all those things, that makes a lot of sense because just like the conjunction P and Q is true only when all the conjuncts are true. Well, P and Q and R and S and T and all that, that's only true when, again, all the conjuncts are true. And so it makes sense how you can sort of build it out like that. Or the P or Q. You can almost look at that backwards and say P or Q false when P and Q are both false. Otherwise, it's true. So P or Q, and then you build an or R or S or T, and all of that all strung together only false when every single one of those disjuncts is false. Otherwise, it's true. You can sort of see naturally how that works out. But then think about the P if and only if Q, if and only if R. You would think it would be the case that when P, Q, and R are all true, then the biconditional, this string of biconditionals is true. Or when they're all false, then this biconditional string is true. Otherwise, it's false. That's not actually the way it goes down. So in order to illustrate this, let's look at our example one more time. And looking at row 1, everything seems to go exactly how we would expect it. P, Q, and R are all true, and the biconditionals all end up being true, and everybody's happy. But let's look instead at row 7. In row 7, we have Q if and only if R, and Q and R have different truth values, false and true. That makes that biconditional false. And then we have P is a false, and then that biconditional is false, so that swaps that to a true. We have P false, Q false, and R true. So we have different truth values for P, Q, and R, and yet the big string of biconditionals would end up being true here. Kind of weird, but really what happens is the difference in those two truth values makes the inner biconditional false, and that matches with the outer biconditional, or the outer proposition in that biconditional. And that's the same thing that happens in proposition 2. So these end up being equivalent, and you could think like, oh yeah, so if these are equivalent, setups here, then we don't have to worry about anything. But it's just not as helpful, right? Like, even though dropping those parentheses we would be fine from a logical standpoint, we would still like intuitively be thinking, okay, all these P's, Q's, and R's, as long as they're all true or as long as they're all false, then these biconditionals are all this big biconditional is gonna be true. It's not gonna work out exactly how we thought. So we'll leave the parentheses in when we're talking about these, even though it would work, because just intuitively it doesn't make as much sense. And again, these shortcuts, the whole point of the shortcuts, the only reason we're doing shortcuts is for our own benefits. So, may as well just keep them in there if it's gonna keep us straight. Anyway, that's all for this one. Go ahead and go on to 4.4, where we'll talk about sets of propositions and also do exercise 4.4.1.